Takes a second or two for it to record. Fun stuff. All right, so we're going to be looking at identify basic facts about network bandwidth equipment. In other words, we're taking a look at the equipment itself. This is one Charlie. Just remember that you've got to get 70% on the tests, which means, Airman Mills, how many can you miss and still pass?
You can miss 12.
Okay, good. So the next one is the AFSC application. End result is you may end up having to toggle through the NSM computer there in front of you in lab and manipulate its bandwidth, because you can put that in there not only in the computer program that you guys are working with, but you can also do it in the NSM. But if the HST 3000, if the HST 3000 does not correlate with the bandwidth that you put in, you're going to get one of those alarm bells. Has anybody done that lately? Everybody?
No, sir.
Okay, so no one's done that by happenstance and getting that mixed up. That's unusual. Guys must be paying attention to detail. We're going to look at bandwidth allocations, network infrastructure, transmission media, carrier system concepts, and hierarchy. Let's take a look at the first one. There are four, count them, four bandwidth allocations. You got conventional, demand assigned, dynamic, time of day. Let's go through each one of them. Conventional means that you're going to get whatever it is, which is a fixed amount, and that's all you can get, no less, no more. The problem is if you don't use it, you lose it, so it's wasted. Here is an example of conventional bandwidth where you can see that we've got four channels. Each one of them has been given 64K. You can see channel 1 and channel 4 is being used. However, channels 2 and 3 are not being used. What does that mean? It means your bandwidth still is 256, but you're only using 128 here. So you're losing 128 as far as bandwidth is concerned. Demand assigned. This one is an exact amount for each of the user. Okay, just remember, this is the internet, and I'll explain here in just a minute when we look at the picture. So what you see here is you got channel 1 is 64K, channel 2 is 9.6K, and then you have a 56K. You got 124 available. What does that mean? It means that when you go to any internet company, mine's AT&T, I have what's called, you got up and down modes, which I got 25 meg is all I'm allowed. What does that mean? Well, I think it's 20. It's either 20 up and 5 down, or 20 down and 5 up. I think that's the way it works. It means that anytime during the week that I need more, and there is more, I could potentially get more. Now, they do put a limit that when you exceed your data cap, they can throttle you back. In other words, if somebody else needs it, they can throttle that back. You may end up having to pay for more, but that's what the internet companies are doing now. Here's what you can get. You can get the max, or you can get underneath of it, but it has everything to do with what your data is and what your data cap does and what's happening during the day. So you may end up being able to play a massive game and have huge amount of bandwidth and so forth and so on during the day when no one's not on it, or like you guys, when everybody is on it in the afternoon, you can't really play very well. So that's what the internet is pretty much looking like. It's called demand and signs. Let's take a look at the next one, which is dynamic. This one says that we've actually exceeded what we can give in an idea that not everybody's going to be on at the same time. Now, too bad you guys didn't go through block 5, which gives you an overview of trunking. And trunking is exactly what dynamic bandwidth is they max out the users in hopes that there will be 1 or 2 times during the day that you're not going to take all the frequencies at that one time. Here's the example that they give you. You got 64K for the first 2 channels. However, you got 128 on 3 and 4, which means you got 384K, which exceeds the 256K. What does that mean? It means that if everybody's on, you're going to get throttled back big time. You have to wait for your time to get in there. We got time of day restriction. This more or less works off the idea of SATCOM. Because you can have priority. For example, does anybody watch Lone Survivor? Yes, no, maybe?
Yes, sir.
Okay. You remember when they had set times to use their SATCOM link to talk to the base?
Yes, sir.
Okay. That's time of day restriction. In other words, you have the priority at that particular time. If you're able to contact and hit the satellite, then you have that priority. You know, like they had that, let's just say it was from 3 o'clock to 3:30, they had that time frame to contact the base. Well, one time they were able to get it, the next couple times they were not able to get it. So it just goes to show you time of day restrictions means that if you're given that allotted time, priority is given to you. And that's the reason why I like to reference the Lone Survivor, because they had priority to hit the satellite to get back to base to give them the information. Now let's take a look at network infrastructure. We've got 2 or more users. I like to call them channels. And they're talking back and forth between using voice data and message traffic across a transmission line. Just remember, you need adequate bandwidth in order for you to be able to do that. In other words, users and channels are interchangeable. However, it's more, you can have more users as opposed to channels. Because if your multiplexer only does 24 channels, you can only have 24 inputs. But you can have multiple users on a channel. Let's take a look at the EIA standards. We got 232 Charlie and 530. For the 232, this one can be equated to the dial-up modem. How many has had that opportunity to hear what a dial-up modem is?
Yes, sir.
Yeah, is that
Was that used in the 90s?
Thank you. Yes. You know, you get the, you know, when you dial.
Is that when you get that little beeping sound whenever you log into the internet?
Yep, exactly. And you'll hear the beep boom, and then it'll link up. Yeah, that's the one. And you hear it all over the internet. When you can find, you know, YouTube actually has the particular one that I hear. And back in the 90s when we were linking up and getting on the internet, talk about slow. And that's that, even though it was doing 56K, where my modem was is 1.5 miles away. You can imagine the lag time. So I didn't have a very good speed. With this one, we take a look at a couple different scenarios in getting the information from point A to point B using transmission lines. The first one is called a balance line. This is what they call a differential transmission, It is twisted pair. In other words, 2 wires. They're twisted. Just like they talk about the Cat5 cables. Twisted pairs, yes, phone lines, Not sure if you're familiar with phone lines. Normally there were two twisted pairs in there. I think the red, green, yellow, and black were the wires, common wires. And normally there was just one pair that they would use. Why they had two, I don't know. When we look at the twisted pairs, though, when they send the information down on the two lines, one of them is 180 degrees out of phase from the other one. So if you take a look at this driver on Alpha and Bravo, off to the left here, what they do is they separate the line out, put one signal on Alpha line, and the Bravo line is 180 degrees out of phase from Alpha. So when it gets down to the other line driver, which is the right side, that line driver puts it together, reinstitutes both of them in the same polarity, and they put it together for the communication. And what made this so unique is the fact that when you're transmitting these two analog signals down the line, what happened is they would get noise along the way. Well, because they were 180 degrees out of phase, when they got put back together, it would eliminate the noise when they twisted them back in phase. This is the earlier segment of noise-canceling headphones. So how does noise-canceling headphones work? Anybody?
It sends the same signal back, and it basically like cancels it out by sending the same signal back.
Okay. Well, you have outside noise, and then they have inside noise. So the outside noise that gets into your earpiece, what it does is it feeds it back into itself to cancel that out. So anything that's not coming out of the speakers and it senses it, it cancels it out by flipping around 180 degrees phase and then putting it back in phase to cancel the noise out. Or in our case, the external noise, or external whatever's happening around us. We look at the unbalanced line. This one is a coax cable. You can see that it says a single-ended transmission. In other words, all the data is on one line. When you look at a coax cable, you have a center conductor and then you have a shield around it. In this case, if you looked at the line driver off to the left, you'll see Alpha has all the digital signals. Bravo is what they call a return signal, but it is grounded. What does that mean? It means all your data back and forth travels on the center conductor. The outside is a noise suppression unit, or the shield is grounded. All the noise that you get on the line is going to ground. It prevents any noise from getting onto the center conductor.
The difference is balanced is two wires, one going one way, the other going the other. That's twisted pair. Unbalanced is a coaxial, which is one wire that goes both ways.
Correct. Correct. EI physical characteristics. Now, I'm not sure that if you have a desktop or if you have a laptop. Some of the older laptops still has a D connector. I don't have one. Wait a minute. Nope. Nope. Anyway, a D connector, just to give you an idea, for those of you who've ever had a desktop that knows what a graphics card is, most of those have a D connector on them. Now, for those of you who still don't understand what a D connector is, everybody's been to the NSM lab, correct? Anybody not?
Yes, sir.
Okay.
Wait.
No, not everybody.
No.
No, not everybody?
Not our prior service.
Okay. All right. So this goes for everybody that's played with the NSM. When you took the HS3000, that's that BERTS that you put the information in, such as your data, you hooked up a cable to the rear of the NSM, right?
That we did.
Those connectors and slots that you plugged them in, those are D connectors. They're 50 pins, but they're D connectors.
Gotcha. No, didn't they used to be used for monitors as well?
That is correct.
Got it.
Nowadays they use HDMI cables and the display ports. Ooh, we lost somebody here. Who did we lose?
Stevens.
Oh.
There he is.
Good, he's back.
Welcome back, Ashton. Merrill Stevens.
All right. So we got the D connector. Everybody understands about the D connector. Let's take a look at what we call negative logic. I've worked with this, and sometimes it is a bear to figure out because you're so used to a +5 is a 1 and a 0 is a 0. Well, negative logic works in reverse. I think the OJ314, which is an air traffic control back in the day, used negative logic. And it was a pain in the royal behind in order to fix it. Because you're sitting there going, wait a minute, I'm supposed to get +5 volts here. Why do I get, 0? So it's just kind of one of those things. EIA 530. So we've gone from the 232 Charlie to the EIA 530. This one is to compensate for what the 232 did. In other words, it's faster. Yes, faster. This one will go between 20K up to 2 megabits per second, all the way up to 3 miles. You'll notice on the back of the NSM, some of those actually have the EIA 530. I think the HISI ports have EIA 613, which is an upgrade. So we go from our balanced, unbalanced to EIA standards 232 Charlie to 530. We're going to look at something called DTE and DCE. Now, if you hadn't noticed, there is a place on the NSM program where it talks about the DTE. We're going to look at the NSM tech manual that describes the DTE and what the HST is doing and what your computer is doing. So what is a DTE? Well, it's a data terminal equipment. It is the source and destination of a computer facsimile thereof. So your computer is that source by transmitting out to the distant end, and it is the destination for anything that comes back in. That's a DTE. Your HST is simulating that when you put in your information to send to the NSM, and it loops back around, and it is also the destination. So inside your NSM, the multiplexer is acting like a loopback, and your HST3000 is the sender and the receiver. And what it's doing is it's looking at the errors that it might encounter when it sends it and receives it. With DCE, this is a communications device that puts all that ones and zeros and it sends it to the distant end. An example would be a modem. So DTE, an example would be a computer. DCE would be a modem. There are 4 different types of transmission medium. You got a twisted pair, you got coax, fiber optic, and wireless. Each one of them is different. Let's take a look at twisted pair. This is basically 2 copper wires twisted. Normally uses baseband only. Balanced line. See where we got balanced at? Now let's look at coax. This is an unbalanced line. This is baseband and broadband. This one is where it uses a center conductor for its transmission. The outer conductor is considered for ground to prevent noise from getting on that line. Fiber optic cable. Bottom line, you're using light. Did you know light is RF?
I knew light was RF.
Technology.
Yep, certain wavelengths. Certain wavelengths. In our case, we're going to use that light to send information over. The nice thing about fiber optic is it's really, really fast and can carry large amounts of information. Also, it has another feature to it where electromagnetic pulses cannot interfere with it. We look at wireless. This is what we're probably using. At least mine is wired all the way through the internet from my end. You guys are probably wireless using your laptops. So that's what it means. And also we can do things like line of sight, satellite, and tropo. The TISR is considered, or the Jerk 239 is considered a line of sight. Same with satellite. And anything going over the troposcatter is considered over the horizon. So again, it's still wireless. Why does everybody like it? And increasing in its popularity? Because you're not walking around with a big line all the time. Which one's
So would you
fast?
say fiber optic is the best transmission?
It's considered the fastest and can carry the largest amount of information. Wireless, does anybody know why wireless, or excuse me, which one's faster, wireless or let's just say fiber optic? Which one's faster?
Fiber optic.
Yep, fiber optic. Why? Because wireless still needs to be modulated and demodulated, and it also has problems going out over the airways with noise and everything else that gets generated. So they got to clean it up on both ends. Next one we take a look at is DSU. We're going to look at another one called CSU. First one, Digital Service Unit. This one is for customer loopbacks, and you can see that it says alternate mark inversion, which is another name for RZ bipolar. When we look at our NSM tech manual, you're going to see that in there. You notice that I've got a big red circle around the diagram here. This is what the DSU is looking at. Let's get a bigger picture here. Did you know that when you have loss of internet and call your internet provider, the first thing that they're going to do is they're going to ping the DSU to take a look at your end. They're going to troubleshoot your end. Why? Because that's where most of the problems happen. That's where they're going to send a technician if they cannot see anything on your end. What happens is they send a message to the DSU. The DSU sends some test signals to, let's say, your computer. If it doesn't get to the computer, it can't resend them, i.e. ping. Get it? Ping rates. So what it's doing is those pings are showing some type of information that, okay, we're synced up, or hey, I don't see anything. Most of the time, it is the customer side, normally between either the router or the lines between the DSU and the router. Most of the times that I've had problems, it's because the squirrels have eaten through the lines. I don't have fiber here yet. Most of the fiber that they are wiring nowadays come with a jacket that even squirrels can chew through. That's if it's on the power poles. The next one we take a look at is CSU, Channel Service Unit. This one is network loopbacks. Again, the internet provider if it is able to see that when they ping you, they get everything coming back and it's good, then maybe the problem is their end. So they will look at the CSU and ping the network servers to see if there is a issue. And it's very possible one of the servers have gone down and another one has switched over, and at that point they can see residual fact of that they got one down. This is all because with these internet providers, they got to figure out where they're going to send the technician. It doesn't make any sense to send a technician to your end when it's not your end, it's the server end, and vice versa. With this one, the CSU does network loopbacks. This one, what they call RZ bipolar with zero suppression. In other words, that is self-clocking and it's sending it back to the servers. The DSU is not self-clocking. So those are two different ideas here, or two different pieces of equipment that the internet providers utilize in trying to figure out where to send the technician. Now, adding to that, if they have to come to your house and they find out something went wrong in your house, they can charge you if they have to come inside the house. They can come inside the house to get to the router, but they will not troubleshoot your system. Is everybody clear on DSU, CSU?
Yes, sir.
It seems pretty logical, but what I get a problem with is students like to confuse the channel service unit with the digital service unit because they think the channel stands for customer. Nope, it's opposite. Channel does not stand for customer. It's the network. Next one.
Channel is a network, correct?
Correct. Hierarchy. We talked about this in our last segment when we were talking about a T1E1 lines back in Friday. This is a logical sequence of building transmission rates in a network. What does that mean? It means that I got to start from somewhere. In our case, you look at DS0, which is 64K, basically a voice channel. That is the maximum for voice channels. And they give it a channel number of 1. Okay, that's DSO or DS0. DS1 or T1 lines, those are 1.55 megabits per second. That gives us 24 of those voice channels. Voice being voice over internet protocol. DS2, this one gives you 6.312 megabits per second, and it gives you 96 channels. And a T3 gives you 672. Just remember, if you need more bandwidth, you got to add to this hierarchy. Let's take a look at a better picture. Hopefully you can see this. I did my best to clean it up. You can see that a T1 multiplexer is 24 channels to make a T1 line. You need 4 T1 multiplexers to make a T2 multiplexer. Start to see this pyramid of foundation of building all the way up to the T5.
Hold on, I'm kind of lost on this.
Okay. In other words, you got to add more multiplexers to get to the next level. So your foundation is the bottom part of the pyramid. You may need, in our case, if we wanted to go to a T4, it looks like on the bottom we would need close to, see, that's what, 96. Oh, geez. 1, 2, 3, 4, 8. Good grief. We're looking at almost, let's just say, a couple hundred T1 lines to get enough T2 lines to go into a T3 line to make a T4 line. It is ridiculously crazy. All you have to know on your multiplexers is you need one more. For example, if your bandwidth is 1.55 and you need, that's megabits per second, and you need something that's around the 2, you need to add another multiplexer in there to get it up to the next higher standard. It's basically building blocks is what it amounts to. That's all hierarchy is. For example, if we have one NSM, okay, and let's just pretend it's 24 channels, we would need 4 of them to get 6.312 megabits per second, which is 4 combined into another one, just to get a T2 line out to get that band. No? I'm still confused there, Mills?
It's a little bit, it makes more sense now.
Okay. So you're adding all of these. I would have to redraw this in order to make you understand how to get to a T4 or T5. Now, it has been my experience that when you get to a T4 line, in other words, it's at 274.176 megabits per second, I'm not sure if you can read it, and it says it's got 2 T4 lines to make a T5 line. I have read that when it gets to a T3 to make a T4 line, you're going to start seeing something called superscripts. What is that? It's errors on top of errors. I don't know who's calling me, but that was rude. I thought I had it turned off. Anyway, the multiplexers beyond that, and this was back in 1999, like you see this one's probably 2020 now. They've probably gone ahead and been able to remedy those superscripts. So it's probably faster, especially when you're looking at the fiber optics, because you can throw a lot more data than you can with these multiplexers. Hopefully that cleared that up for you. So what does it mean? It means aggregates being put on another aggregate and many aggregates being put on another aggregate to build one that's just ridiculously fast and huge. Building blocks. It's all you got to need to know about hierarchy. So we looked at bandwidth allocations. So Airman Thomas, what were the 4 bandwidth allocations that we went over?
Could you repeat that? I didn't hear you, sir.
Sure. We discussed 4 different types of bandwidth allocations. What are they?
Conventional, demand assigned, time of day, and dynamic.
Good. When we looked at transmission media, we described 2 lines. One was balanced, the other one is unbalanced. Juarez, can you tell me anything about the balanced line?
You said a balance line, correct?
Yes, sir.
That would be like the twisted pairs, since the 2 wires carry the data.
Good. What else?
Different transmission, isn't it?
I'm listening.
Oh, there's more to it. I know one wire, the data on one wire is like out of phase.
How much?
Like 180 degrees.
There you go. 180 degrees out of phase. And why do we do that?
I am not sure.
Anybody?
To send the signal back,
No. Why do we put
like noise cancellation.
There you go. Noise cancellation. Marshman, what's a unbalanced line? Can you describe that?
That would be the coaxial cable.
Okay.
I'm drawing a blank here.
Thomas, can you help?
I'm also drawing a blank.
Mills?
It is one wire that goes both ways.
Okay. What happens to the other one?
Oh,
The second wire is grounded.
Yep.
yeah,
And
it's
why is it
grounded.
grounded?
It's 180 degrees out of phase.
No.
No.
Why is
It's
it
just a
grounded?
single-ended transmission.
It is a single-ended transmission, but why is it grounded?
I know it has to do something about returning the signal, correct?
Okay, it says it returns the signal, but it's really not the way that they do that. Returning the signal is actually grounding the signal to where no noise gets on it. That's what it means. So you have one that goes, the center conductor goes both transmission and receiving. The outer shield is grounded, so therefore we prevent any noise from getting onto the center conductor. That's the reason why coax cable is 99.9% time faster than twisted pair.
When you say no noise gets on like the signal, you're talking about like static noise,
Yep.
like unwanted sounds.
Correct. Okay, so let's think about this. You look how far apart between the center conductor and the shield is. It doesn't look like it's a whole lot, does it?
Oh, sir.
Okay, but let's just pretend that somewhere down the line, if you did not have it grounded, where does all that noise go to?
I'm guessing if it's not grounded, then it would just go on the data signal noise.
It's very possible it will create problems because
It
where,
will interfere with it.
yeah, it will interfere with it. Because when you put that connection, let's say, onto the back of your TV, one side, when you screw that in, that's a metal piece. Well, that metal piece does have some properties that it's close enough to that center conductor that any noises on that can get grounded. What happens if you have a lightning storm? If it's not grounded, guess what you just destroyed? Your TV.
Your TV.
Yeah, or your internet. So a lot of people don't know this, but we have what's called a double-aught series tech order. I call it a Z series or a double-aught, either way. I've read through it, and one of the things that they tell you is do not mix your communication ground with an electrical ground. Because electrical grounds, what are they meant to do? Well, lightning. Well, with a comm ground, it also does the same thing, but you got to keep them separate, which is one of the reasons if you don't keep them separate, they'll develop eddy currents. And let's just say you get a strike at your house, it is very possible that you're going to have some type of electronics, get zapped. So let me give you a couple explanations here or examples. It did not dawn on me for a while when I first got down here. There is a lot of lightning storms that happen here on the coast. It's nature of the beast. You're going to get them. What is amazing is the fact that how many times I've had to replace, and this is before all the other electronics is I would, after a lightning storm, I'd have to replace a TV, or I'd have to replace a VCR, I'd have to replace a DVD player. So it got old quick, and I didn't really truly understand it until I started reading the Z-Series TO about separating out the comm ground versus the electrical ground. What I notice is the ground outside, and you can go look at any ground on a residential house, they being, let's just say, AT&T or Verizon or any cable company, what they do is they tie to the outside ground of your electrical. Interesting. So what I found out is in our electronics, and we're talking Satcom, a couple other places where they do what's called multiple grounds, deep grounds, where they tie the comm ground to it as opposed to the electrical ground, which is separate. And what that does is prevent a lot of noise from the electrical line, and it prevents any lightning strikes from getting back into the equipment. All right. The moment I did that, I have a metal roof. I still run my internet and everything while lightning goes on. I've had lightning hit a couple poles out here, and of course we lose power and it comes back up. My next door neighbor gets frazzled because he just lost a TV or something like that. And it's like, well, that's because your comm ground is on your electrical ground because of that. So let's fast forward about, I want to say about 6, 7, maybe 8 years ago at Jones Hall. We had a lightning strike. We didn't know where it hit first, but it hit close to Jones Hall. 2 days later, we found out that it took out the whole Block 9 SATCOM system. Why? It wasn't properly grounded.
It got fried.
Yep. I think there was a little over $2 million worth of damage for all that SATCOM gear in there. It was a lot. It was a lot. Holy cow, was it a lot. All right. Is there any other questions on that? Yeah, sorry about the stories, but it just gets the point across trying to get you guys to understand the grounding on a unbalanced line. If you don't have it grounded properly, you're going to have problems with it. All right, I have 124. Let's take a couple minutes, or let's take 5 minutes, come back at 1:30, and we'll go over the rest of the stuff. Okay?
Yes, sir.
All right.
Yes, sir.
Break.